Okay, so let's start now. So today we will be just seeing some of the gate PYQs and then base theorem and some more questions. Okay, but before that, I wanted to solve any doubt that you have till from the lectures that has happened till now. So there was one question that was I mean asked in the group. Let me just solve that question first. The question was related to tree method, right? Yes, I'm good. Thank you, Gaurav, for asking. Okay. So that question was related to tree method. So let me first solve that question. Okay, I'm sorry, I have not gone through whole discussion. But if you have any doubt, you can just ask me here. So the question was like this. Someone has framed the question, which was something like this. I don't have that exact tree that you were having, but at this level you were having A, right? A, huh. So you like either A has happened or A complement has happened, and then yeah, Abhay has asked, right? So then B has happened, and then maybe at this level, people were having B. So B has happened, or B complement can happen, or here B or B complement, and then C and C complement, right? So here C and C complement. So like that, right? So okay. So this was the tree. Now here the edge probabilities were given to us, which means that let me maybe rotate this tree. No, that's fine. Right. Okay, that's fine. So yeah. So basically, like edge probabilities were given to us. So do you remember what was that? That probabilities that we were having in the question? Okay, x here, x and 1 minus x. Okay, tell me this left hand probability. Y. Okay, 1 minus y. Okay, let me just do it y. Okay, 1 minus y. Z, 1 minus z. Or maybe let me do y 1 minus y and then z 1 minus z. Okay. So let's suppose these are the probabilities. And here you have some other probabilities. Maybe let's suppose w 1 minus w. Okay. And suppose this is the tree diagram that we have. Now, what are the probabilities are given to me? Can I say the probability of C given B comma A is basically, what is that probability? Can anyone tell me? Probability of C given B comma A is Z, right? Yes, nice. So this is the probability that is given here. And now if I ask you, what is the probability of ABC? What is the probability of ABC? X by Z, right? Yes, X by Z. Okay. Now, actually, many probabilities are given based on this tree diagram. And now the question was, what is the probability of C given B, right? This was the question. Am I correct? Let me just check. I have that question. Given B, yes. Okay. Okay. So this was the question that was asked. That what is this probability? Let's just find out this probability. I think this is my voice is clear, or this is low voice. Can you confirm? Clear. Okay. Now let's just find out this probability. So this is a question. Okay. Now from here, what you can say, what is the probability of C given B? It is same as saying probability of B comma C upon probability of B, right? No, probability of ABC is not same as probability of C. Probability of C is different. Can anyone tell me what is the probability of C? So probability of C is this node, this node, this node, and this node. You need to add 4 probabilities here just to get the probability of C, right? You need to add 4 probabilities. This one, this one, this one, and this one. Okay. Yes, Akash, that is correct. So that is not probability of C. This is probability of ABC. Okay. So now let's just find out the probability of BC and probability of B to finally get the answer. So what is the probability of BC? Let's just see here. See, this was the question that was asked. Now let's just find out the probability of BC. It is basically probability of BC, right? Sorry. Can you find out probability of BC? Can anyone help me? How we can find out the probability of BC? Nice. Marginalization. Yes, we can just do the marginalization, which means I can just introduce A here because I know the probability of ABC, right? Which is X by Z, right? And then I can say, let me just introduce A and A complement basically, right? So that's how you can find out the probability of BC using the marginalization. Why I'm doing the marginalization? Because you don't have probability of BC directly, but you have the probability of ABC, which is X by Z. So which means you can find out the probability of BC using ABC, which is X by Z plus A complement BC probability, right? So whatever it is. Let me just say this is X by Z W A or B, some variable, right? So what was that variable name that they have used in the question? That was A. Okay, this is 1 minus A. So what is the probability of A complement BC? A complement BC will be 1 minus X W into A. Right? Now that's how you can find out probability of BC. Now let's just find out probability of B also. What is the probability of B? How you can find out? Again, marginalization, isn't it? Yes. Or you can say, you can just sum up these two probabilities. If you sum up these two probabilities, isn't it same as the marginalization? Isn't it same as the marginalization? Which means you are basically saying A and along with the A complement. Basically, these two probabilities, even if you do marginalization, that it will look like this, which is same as summing up these two probabilities, right? AB, and A complement B. So you can sum up these two probabilities, which is same as marginalization. So, I mean, you can find out, right? This is X into Y and A complement B is 1 minus X into W. So this is X into Y. This is 1 minus X into W. So now you have probability of BC. Now you have probability of B. So you can find out this probability, right? That's how you can find out this probability. Let me know if there is any doubt here. That was a good question, actually. Like, to be honest, it was a very good question, right? So whoever has framed it, it was really a good question. सर इन द प्रीवियस लाइव सेशन आपने बताया था कि प्रोबेबिलिटी ऑफ C1 गिवन B1 इक्वल टू प्रोबेबिलिटी ऑफ C1 गिवन A1 कॉमा B1. नहीं, मैंने तो ऐसा नहीं बोला. लाइक प्रोबेबिलिटी ऑफ, यू आर सेइंग C गिवन B इज सेम एज प्रोबेबिलिटी ऑफ C गिवन A कॉमा B. No, that was only with respect to that particular question. That is not universal true. That was just because I think the starting point was fixed. That was like that. Now the starting point is not A. Starting point could be A complement also, right? I mean, यहाँ से अगर मैं बोलूँ, let's suppose this is S, है ना? तो with respect to S it is fine. मतलब यहाँ पे A की जगह S होता तो that is fine. Okay? But with respect to A it is not fine. I mean, a starting point, you write the starting point, you don't write the starting point, does not matter. Given the starting point is very trivial information that doesn't add anything. But given the A, it matters because you can start from A complement also. I mean, given the A is not the only option here, right? Okay. Cool. So now let's just do one thing. Let's just find out few other probabilities using this tree diagram. Whatever probability that is coming to your mind, let's just find out that probability. Do you have anything in your mind specifically? Any random probability. Just tell me any combination of ABC. Is Z equal to A? Z is this, A is this. No, there is no relation at all. There is no relation between Z and A. So this is Z, which is basically after AB what is happening, and after A complement B what is happening, there is no relation. Okay. So superior is saying that can we find out probability of C given A? Okay, probability of C given A. Oh, nice one. So you're skipping B. Nice, nice. So can you find out this? Do anyone knows that? I think in the recorded video, I think we did thing right, did this right in one of the recorded video. I think the last recorded video. So how you can do it? Let's just do it. I mean, if you're skipping one level here, you're skipping this level completely. You are saying that A, like A has happened, then what is the probability of C? That's what you're saying, right? You're skipping the level of B. क्या करें? Skip तो कैसे कर सकते हैं, right? We can't just skip like that. Then what we need to do? We need to do, just let me know that word that I'm just looking for. What do we need to do? Marginalization. Yes, marginalization. So we need to do marginalization, right? So let's just do the marginalization, because you can't just skip B, but because you have to introduce B, because that is how the experiment has been conducted. So everything is an experiment here in the probability. So the experiment is like this: you may be tossing a coin, and then you may be rolling a die, and then you may be again tossing a coin, whatever, right? This is a sequence of event. Like, I mean, tree is basically for the sequence of events. You can't just skip a level. If you want to skip a level, that's okay, but you have to marginalize. So now tell me, is this a correct way to marginalize? Is this a correct way to write B in the marginalization? No, right? Marginalization happens with respect to C. I mean, you need to write with C. So this is not the right way. You need to write with C, which means you will say this is equal to probability of C comma B given A plus probability of C comma B complement given A. Okay. Now let's just do this. Probability of C comma B given A. Okay, so how to find out probability of C comma B given A and then this probability? This is C, right? Can you help me with these numbers also? Let me write B, okay? So maybe this is B and 1 minus B. Superior is saying that why not we use C and A divide by probability of A. Yeah, you can use it. I mean, okay. So this is one of the way to marginalize and then find out this particular value. So we want to see our aim is to find out this particular value, right? Now, what I'm saying is that you can't just find out this particular value without introducing B, because that is how the that is how the experiment is conducted, isn't it? Can you directly find out the relationship between A and C without even talking about B? No, right? Because that is how it has happened. Now, if you want, you can do it, but ultimately you have to introduce B somewhere. Okay, which means if you want, you can do it. Like, I don't have any issue. Maybe I can just pause this particular discussion for a moment of marginalization, and then let me just follow what you are saying. Okay, and then at some point in time we need to do it basically. Okay, probability of C comma A given upon probability of A. This is what you're saying, right? Now let's just see if you can find out these probabilities. Okay. So probability of A, can you find out? I think that is easy. Can anyone tell me what is the probability of A? Looking at this diagram, this is clearly X, right? So that's very easy. That is very much given in the diagram, which is X. Now, what is the probability of C comma A? Okay. Again, see, there is no direct relationship between C comma A. Then why not do something which is what we call marginalization, right? Why not marginalize? So basically, I don't think we can directly compute it. So let me just introduce B. Okay. Now, ABC, what is the probability of ABC? I think XYZ. Plus, what is the probability of AB complement C? AB complement C. This is X into 1 minus Y into B, right? X into 1 minus Y into B. Yeah. So divided by x, which is equal to yz plus 1 minus y into b, right? So that's how you can find out this probability. I mean, you can find out any of the probability, whatever. I mean, if the tree diagram has every information, like every edge value, then you can obviously find out any of the probability. Okay. So Twinkle is saying she had just joined. I think there is okay. There is no particular any lecture that I remember that. I have not spoken her name. So anyway, so Twinkle is saying that she had just joined. Now, what is the question sir is solving? So there was one question that was on the Telegram group, and then we were solving that particular question. Why did x cancel? Yeah, so I was just about to analyze that. Okay, so by the way, the final answer is okay to everyone, right? Now let's just see that is there a way to directly come up with this answer? See, we did some computation and then we finally come up with this answer, right? Now I wanted to just check if we can directly see this answer intuitively, क्योंकि x तो finally cancel हो ही गया ना. So let's just see if we can directly see this answer intuitively. See, what I'm saying here is that this probability is equal to this, right? Now, let me go to this page. Let me paste it here. Let's just check if you can see directly. This is yz plus 1 minus y into b, right? So given A, what is the probability of C? So what you're doing, you're just adding out these two, right? Which means you are completely ignoring this branch, which means you are saying that, okay, this C and that C doesn't matter to me, right? I mean, this C doesn't matter. Similarly, this C also doesn't matter, right? This C and this C also doesn't matter. So Rohan, whatever you're asking, I think it is not related to this particular question. Lecture 1B you are asking. So maybe you are saying, I think some typo is there. So that might be some typo. Let me just continue with this particular question, okay? And then I will just address your doubt little later. So what this is saying is that let's not worry about this particular branch entirely. Yes, Sakshi, that is correct. So do you remember there was one question of gate PYQ that we were solving there, and then we were saying that Monday has already on Monday you have already chosen computer science. Now let's talk about other things, right? So basically this probability was 1 and everything else probability was 0. Now given that you already have computer science, you completely ignore other branch, right? So here also, given that A has already happened, you completely ignore anything else. Now you just start that this is a starting point. And then you find out the probability of C. Isn't it so nice? Probability of C is yz plus 1 minus y into b. The good thing about is this, that you don't need to know all of this intuition and all. You have to just follow the formula. You have to just follow the tree method. Okay. So you don't need to know all of this intuition and all. I was just trying to connect the dots. You just follow the formula. You just follow the intuition. So you just follow the tree diagram and you will get your answer. So one of the way I think Supriyo was suggesting that why we are not directly going from here to here and then we are not solving. Why we are not solving? Yes, you can do this. So this is, let me just call it as a method 2 or method 1 or whatever, right? So let me just call it method 2. Let me just continue my discussion from this method where Supriyo was saying that we can marginalize. I mean, we can first open and then we can marginalize. Seems like it was a good method. I'm just taking a risk of doing other method, which is basically I'm first marginalizing and then maybe I will do something, but let's just do it. Okay. Let's just call it as method 1. Because that was the first thing that came into my mind, that, okay, why not introducing B? Because we have to anyway introduce B. We can't just skip one level, right? So now from here, you can understand the CB given A. How to find out this value, which is CB given A? Can anyone tell me directly? With the intuition that we just developed, can anyone tell me directly? What is this value? Yes, this value is by Z, right? Because given A, let's just forget about anything else. And now they're asking about the CB. CB means given, just consider this as a starting point. And then what is the probability of CB? It is just YZ, right? In the reduced domain, you can talk about it, right? So this is YZ, but let's not go with the intuition. Let's just use the formula. So from here, yes. So from here, probability of it is ABC divided by probability of A. Now, what is the probability of ABC? I think X by Z. This is X by Z divided by X. So finally, it will be by Z plus probability of A, B complement C. By the way, do you think that suppose I give you these probabilities as just numbers? I mean, I just give you a random numbers without the tree. I just say that, okay, this probability of age X, probability of A, probability of B given age by, and I give you all these probabilities in some table or something. And then I ask you to calculate this. Do you think it will be without the tree diagram, it will be that much easy? I think it will be scary, right? You will get scared if I give you so much of probabilities. So, but with tree diagram, actually things become quite easy to understand. Okay. So A, B complement C, A, B complement C. It is X into 1 minus Y into B, right? Plus X into 1 minus Y into B. And then what is this probability of A? Probability of A is again X. So finally, you will be having by Z plus 1 minus Y into B as your final answer. Right? Okay. Let me know if that is correct. Oh, sorry, that is understood. Okay, you understood this, right? Now let's just move. Let's just move to maybe different method I can use. So let's just say that, let's just see, actually I don't know, but let's just see if we can have any other method. So let me call it method 3. Okay. Maybe let me just copy this particular tree diagram. Okay. So what we wanted to know, what is the probability of C given A? That is what we wanted to know, right? क्या हो सकता है? Marginalize पहले कर दिया, बाद में कर दिया, इसके अलावा what we can do? Okay, C given B. Okay, you want me to solve C given B. Probability of C given B. Okay. I think that was just we did, right? That is the first thing that we did. Probability of C given B. So others, have you joined late or like, I mean, have you joined just now? Okay. So you can just watch this video, like that is also easy thing. You can just watch it. Okay. So let's just see if we can have any other method as in method 3. Probability of C, I want actually B, to like we can't skip B, that is for sure. That is what I know, that if B is there in the tree diagram, you can't just skip B directly, either intuitively or marginalization or whatever you do, you have to introduce B. I think यही possible है. Let's just find out some other probabilities. Okay, so instead of that, do you have anything else in your mind? Any probability? Okay, let me just think about it. Can we find out probability of A given C? Okay, I think that is doable. How you will do it? This is probability of A intersection C upon probability of C. Actually, this is the reverse probability that I'm interested in. So instead of finding that A, B given, I mean, probability of C given A, B or something like that, I'm just finding out the reverse probabilities, which means I know that C has already occurred. Now I'm just interested to know that C has occurred. Then what was the probability that it has occurred with A? Okay, with A, which means it has occurred with this node, not with this node. What is the probability? So this is what I'm interested to know. So basically in machine learning, there is a particular, I can say, particular area of, research or area, like a particular topic that is called causal inference. Causal inference. In causal inference, they talk about this reverse engineering, reverse inference only, like they talk about this Bayesian inference and all. So this Bayes theorem is very little thing there. They have a proper topic that is called probabilistic graphical model, PGM. probabilistic graphical model, there is one special topic in machine learning. And in fact, there are books. There is a book that is called, that name, if I recall correctly, Murthy. The book author name is Murthy, and the book is about the probabilistic graphical models. And there they just have these graphs and all. Okay, they just have these tree diagrams, graphs, just to, you know, and there's a very complicated and there's a very different area of discussion. But yeah, that is particular area in machine learning that is called probabilistic graphical models, and that is, I mean, very much popular nowadays with the causal inference. So that is related to the causal inference. Anyway, you will get to study probably that in your masters if you choose to take any good machine learning course. I mean, in the introductory machine learning course, that might not be there, but you have to take some advanced machine learning course to study probabilistic graphical models. Okay, Manish is saying, sir, I tried gate PYQs but not able to make tree because of the language. So we will solve the gate PYQs, okay, today only. So let me just continue with this. So probability of A intersection C. What is the probability of A intersection C? I think you need to again marginalize, right? मैंने निकाला ही है ना शायद. A intersection C we already did, I think, right? Yeah, that is XYZ plus X into 1 minus Y plus B. XYZ plus X into 1 minus Y plus B into B upon probability of C. What is the probability of C? I think you need to do it this node, this node, this node, and this node. So there are 4 nodes. You need to actually write the 4 summations here, right? So 1 term, 2nd term, 3rd term, and 4th term. So maybe you can do it, okay, at your own convenience, right? So I think that is easy. You can just find out XYZ plus plus something plus something. So there will be 4 nodes, and you can write those 4 nodes here, right? Okay. So whatever probability that is coming to your mind should be solvable using this tree diagram. Whatever you think of, doesn't matter at all. Once you have the tree diagram, whatever probability coming to your mind should be solvable. Do you have any other thing in your mind? Okay. Abhay is asking, probability of C में भी marginalization use हो रहा है क्या? Probability of C. हाँ, मतलब you can definitely call it marginalization. Yes, you can definitely call it marginalization because here you are basically doing some summation, right? So with the probability of C, you can say you are marginalizing not just A or not just B. You are marginalizing 2 things, A and B, right? So if you marginalize 2 things, then how you can do it? You have to do it with, I mean, you can do step by step, basically. Maybe you can first introduce A and then introduce B. Let me just try doing it. So basically, if you do marginalization with A, you will get something like this. And then you do marginalization with B here. So you will be getting probability of ABC plus probability of AB complement C plus here probability of A complement BC plus probability of A complement B complement C, right? So that's the marginalization. So basically, if you have to find out the probability of C, you have to marginalize with 2 events, which is A and B. You can't just marginalize with 1 event, क्योंकि 2 event है ना C से पहले, from the starting point to C. Okay, and which means you have to sum up these 4 nodes, isn't it? This is ABC. See, this is ABC. You have to sum up this. You have to sum up A B complement C, A B complement C. You have to sum up this. And similarly, these are the 4 events that you have to sum up. And I mean, 4 probabilities that you have to sum up to get the probability of C. Okay. So now I hope everyone is quite comfortable with the tree diagram. Okay. Superior is saying, if on the 3rd level, there was some other event along with the C. Okay. Yeah, you can definitely have. I mean, that should be mutually exhaustive. So whatever event you are having, so see, either you have C complement here. Just a second. In which lecture you taught the marginalization? Lecture number I don't remember particularly, but there is a topic, I think total probability, right? I think 3A. 3A is the lecture number, maybe 3A. Okay. Have you seen the 3A? So I think 3 is the lecture number. The heading was total probability. Yes, along with the C, you can have any other event also. Okay. So in for the gate purpose, basically you don't need anything else. I mean, I think that is more than enough. So you don't even be needing these many events for the gate purpose, but it is good that we did some practice, right? Even if you remember that I told you some factorization, right? I told you like to do some factorization and all, right? So you don't need to know all of this factorization for the purpose of gate. Okay, I mean, if you just factor it out, this will be probability of D into probability of C given D and then so on, right? नहीं नहीं, अच्छा ही है, मतलब इतना ज्यादा नहीं किया है अभय अभय सिंह, हमने कुछ ज्यादा एनालाइज कर लिया। नो, इतना ज्यादा तो नहीं किया है, मतलब आधा आधा घंटे की 2 वीडियोज हैं, आई थिंक एनफ, मतलब इतना कुछ नहीं किया है। दिस इज एक्चुअली रिक्वायर्ड ऑल्सो। ओके, वट एवर इज रिक्वायर्ड वही वही हम लोग पढ़ रहे हैं। आपके लिए तो कम ही होगा नहीं नहीं, ऐसा नहीं है। मतलब मुझे लाइक इट्स नॉट लाइक कि मेरे लिए कम है, मैं लाइक वी ऑलवेज टॉक इन टर्म्स ऑफ द गेट पर्सपेक्टिव। तो गेट पर्सपेक्टिव के हिसाब से इट वाज गुड। Okay, now let's just solve these questions. Now they are saying which of the following is equal to this particular probability, right? Let's just see that which of the following is equal to this particular probability. काफी ज्यादा जल्दी कर दिया यार। B, everyone is saying C. Okay, like I have not even read the question. B given C intersection A. Yeah. So how to do this question? This is probability of B comma C given A, right? That will be equal to see, if this given A is given, then can I just for a moment can I just skip this given A? Can I just say probability of B comma C equal to something which is probability of C into probability of B given C? Or maybe if you want, I can write probability of B into probability of C given B, right? I mean, it depends whether you're coming from left or you're coming from right. So like, let me just write this BC as something like this. Okay, so probability of C. Okay, let me write something like this, which means this is equal to probability of, I mean, probability of BC is equal to this one. So if I do given A, then everywhere you will be writing given A, right? B given A into probability of C given A comma B. I want probability of C. Okay. So let me use this formula. Let me use this one. Okay. Let me use this one. So this is probability of C given A, right? I mean, C given A into probability of B given AC, right? So that's how you can solve it. So that's why C is the correct answer. Is this okay to everyone? How we did it? Have you understood? So how we did it? Basically, we have first written this, and now everywhere given A, right? Everywhere given A, and that's how we can do it, right? Okay. Now they can ask the similar question in multiple variations also. So let's just see if other variations are also possible. I'm not sure if this will be a little beyond gate or not. So that's why I'm just writing optional. Okay. Optional variations that could be possible. Now let's just say that I have AB and here I have CD. Okay. Or maybe just for the sake of example, CDE. Everyone solved using the tree method, sir. So now, which one? Using the tree method, you want to solve it? Actually, not required. I mean, direct formula is applicable. No, direct formula, if you have given A, so just ignore this given A first and then write the simple formulation and then write given A everywhere. Okay. And if you want, you can just analyze using the tree diagram also. Okay, let me just try doing it using the tree diagram. Actually, it will be overkill. Like, tree diagram is there to make our life easy, not to make it complicated. But yeah, if you want, let's just do it. So see, here you have A. Okay, given A, right? So okay, let's just start with A complement. Given A की बात हो रही है, तो I mean everything is given A, so let's not even worry about A complement branch. Okay, have you understood what I'm saying? So since I'm only concerned about given A, Okay, so we will not worry about this particular branch because everything is given A, right? Now, because the question is about given A. Now here you can have B. B फर्स्ट रखना है कि C को फर्स्ट रखना है? B and C पूछा है. I think ठीक है, देखते हैं. What they have asked is that probability of B intersection C given A. In the tree diagram, B intersection C given A. Okay. Okay. So I think we can rewrite this as probability of ABC upon probability of A, right? And then, okay, probability of ABC, I can find out probability of A is there. Actually, it is very much direct. Let's suppose this is X, Y, Z. Can anyone tell me intuitively also what is the answer here? Intuitively, can anyone tell me? If I don't even write all of this, what is the answer? These are the X, Y, Z. Answer is, like if someone asks me to find out this probability using this tree diagram, then you can say given A, which means you don't even worry about all of this. Given A, which means y into Z is the answer here, right? Y into Z is the answer here. Now maybe you need to check that which one is having the same answer. So given A, probability of C, and like actually I think the formula is directly better instead of calculating all of this using the tree diagram, right? As I already told, that formula might be better in this case. Okay, I mean you can do it with every option, but it might not be worth doing it. Okay. So let's just see if some other variations are possible here. So suppose if I just rewrite it, then just let me know if this particular formula is correct or not. Okay. Okay. Just let me know whether I can write it like this or not. A, B, C, E, C, E given D upon probability of C, E given D. Can I write like this? Just think about it. By the way, has any one of you received Go classes portal? This Go classes portal, has any one of you received? I think, yeah, Go classes. Anyone? Okay. So do you wish to get some goodies? For that, you have to perform good in examination. I mean, we will be obviously circulating these goodies once you get good marks in the mock test AIMT. Okay, these things. Yes. So if you get good marks in mock test, then we will be sending them to you. Okay, let me know if that is okay to know. That is correct the formula or not? Gaurav is saying it is correct. Yes, Akash. There are shirt, mug, and there will be another set of goodies for the next year. Obviously, I mean this will be bigger and better. So there will be different variations of the goodies also. Hoodie we have, but we have not circulated them. I mean, I and Deepak have have hoodies, but actually hoodies were there when the even winter season was went away. So we are we are just saving those hoodies for the next year. Okay, so now let's just see. Now let's just see that if this formula is correct or not. So let's just check it, true or false. Let me write true or false. Okay. So see what we can do to verify it, that here everywhere you can see one thing. What is that? In the right hand side, you can see given D, isn't it? Given D. Now, if you are seeing given D, then what does this mean? Then it means that let's just skip this D from here also, which means like let's just write the formula without D, which means let's just write some formula given C. First of all, tell me, can I treat any of this as one event? Can I treat CD as one event? I mean, for the sake of writing, and E as another event. Can I treat the CDE as one event? Because everything is intersection, right? So let me just tell you what do I mean by that. Suppose you just open this up. It will be probability of ABCE upon probability of C. Is this okay to everyone? No, I'm not ignoring D. Don't worry. Like, we will come back to D. I'm just asking whether this is correct or not. I have ignored D just for a moment. Why? Because everywhere here given D. So I will put given D later. I'm just interested to see if this is correct or not. This is correct, right? Now, since this is correct, now what you can do, you can write, can you write given D at both the places? So given D here, given D here, given D here. Okay, just a second. Let me just copy this. So basically, this is what we know. And then I'm just asking, can you do given D at both the places? Then you are saying, yes, you can do it, right? So basically, it will be comma D, given D, given D. Okay. So is this correct to everyone? So basically, we have this. Now from here, can you go to here? This is my question. From here, can you go here? Now, whatever I have written earlier was same thing, right? A, B, C, E given D, C, E given D. Since these two are same thing, so I can say this is true. This is true. Right? Okay. I hope you understood this. So basically what I'm doing here is that I'm first writing. So this, I wanted to prove this. So I'm first writing this particular, like I'm first writing this particular thing. I'm just treating the CD here, could be one event. It could be just one event, but I'm treating the C as one event, C as a pair, which is coming together, and D as a separate event. Okay. So that's how I'm solving this particular question. But obviously there are many variations possible for this particular example. So let's just see whether this is true or false. Okay. So just let me know if I can write this particular thing as something like this. Can I write something like this? Is this true? Okay. So which one, Twinkle, you are saying this particular question? Previous part. Okay. So previously, what is happening? Have you understood this particular thing? That how we are writing it? Have you understood this particular thing? Okay. Now, if you are writing given D, then everywhere just write given D. See here, C is already given. You are just writing given D here. Now here, given D. That is all. That is all you need to do, right? Okay. Okay. So it is easy. Like, you just write given D at both the places. Now I'm just asking whether this is true or false. Right? So you can definitely do it, right? Okay. Okay. So this is true. Okay. This is true. Now let me know let me just write another variation. Let me know if that is true or false. So let me write probably some other variation. Just let me know. Is this true? Is this also true or false? Just don't worry about CD. Okay. Just don't worry about CD for a moment from both the places. Without CD, is this fine? Without CD, is this fine? Without CD, at least is this fine, right? This is fine. Now you can just put at both the places, you can just put CD. CD, given CD, given CD, given CD. Okay. How are you solving these questions? Did you cover this in new lecture? No, like actually, like, I mean, I have not covered it as such because it is just optional thing. So like we have covered just one formula, which is AB equal to probability of A intersection B upon probability of B. This is what we have covered, right? Now, if you know this formula, then you can do anywhere. You can do given C, given C. I mean, you can do given C, given C. Basically, if you have this basic formula, so maybe I can go to the next page. See, what I'm saying here is that you have this formula, right? Which is very basic formula. A given B, which is equal to probability of A comma B upon probability of B, right? Now you can from this formula, you can say that this is also true. Why this is true? Because in this formula, you can say you are just saying given C everywhere. So from here, you can say this is also true. Okay, this is very basic formula, but from here you can say this is also true. Why? Because given C at both the places. This is what I told, right? No, given B is already there. Now you just write given C, extra C. Do you recall there was one slide that I was having where this was the rules of probability. This was the rules of conditional probability, right? Conditional probability. There was one slide. In that particular slide, there was one particular instance where I was having base formula, right? Base formula. So here I was having, on the left hand side I was having this formula, on the right hand side I was having this formula, right? Yes. So anyway, like you just write given C at both the places. So if you have the base formula, then you can do it. You can extend it to anything. So here, if I just want to check whether this is true or not, now what can I do? I know one thing. Okay, let's just ignore for a moment. Let's just ignore CD because CD is at given side. So if you ignore CD, then you can just write a simple formula which is AB given E. Now can you just open this up? It will be AB E upon probability of E, isn't it? Now you write given CD, given CD. So given CD, you write here, given CD, you write here, given CD, you write here. So that's how you can say that from this, you can come to this. Okay. So anyway, this is one optional variation. I was just saying that one particular formulation can be written in any form based on your requirement. Okay. Based on whatever is given in the question. But now you should be comfortable in exchanging these things. That's what I'm saying. Although this is very much optional, I don't think gate will ever ask this. Okay, but yeah, still it is good to have a little bit of practice. So gate may definitely ask this question. So this is a question that gate may definitely ask. But yeah, these one or two that I just told you was just optional variation. Okay, but yeah, you should be comfortable with at least this particular question. This is definitely gate can ask. I mean, there is nothing fancy here. Gate can definitely ask this. Is this okay to everyone? Let me know if there is any doubt here. Okay. Okay. So now let's just move to the how you are solving it with this approach. With what approach? So you want to solve this? I have just seen that. Okay, without given A, how does it look like? Without given A B C equal to this. Now you just write given A both the places, right? So from here you can go here. Can you show the last slide of the question? Sir, given from A, why ignoring the starting? Given from A, why ignoring the starting? I'm not getting you. So see, A will happen and then something will happen, right? So is some event that is happening. It is not that A is starting. It is not that A is starting. A is happening after like A is one event there. Okay. Anyway, like I think you are getting, I mean, you are getting confused by overthinking. Maybe you spend little bit time in this question, then you will get to understand. Okay, Swapnil. So Nutan is asking, can you show the last slide of the question? Last slide of the question. This one. Okay. So what is the doubt here? So see, probability of A given B is A comma B upon probability of B. And then you can do just given C at both the places. Right? So I hope that is fine. Let me know if there is any doubt, anyone here. Okay. So now, yes, C is the correct answer. Now let's solve this question. Which of the following is true? That's what they're asking, right? Is A true or B true? Or both are true? A is true. Okay. B intersection A. So let's just see the Venn diagram. This is A. Let's suppose this is B. Now B intersection A is this one, right? And B complement intersection A is this one. So I think this is completely A. So A can be written as B intersection A union B complement intersection A. So since now, can anyone tell me that why we can write something like this? Why we can write the summation B intersection A plus probability of B complement intersection A? Why we can write the summation? This is, yes, disjoint events, mutually exclusive or disjoint, both are same. Okay, these are the disjoint events. Since this event and this event are completely disjoint, right? There is no overlap between these two events. So that's why you can write this as plus summation. So that's why A is true. And that's why B is false, because A and B are having just this difference, I think, right? So B is false and A is true. Is this okay to everyone? That A is true and B is false. Okay. Shakshi is talking about some symmetric difference and all. Itna higher mathematics, I don't know. Okay. I mean, like I might know, but since the set theory is not covered, so I will not go in those kind of things. Okay. Now I think we can move to the next question. Okay, I think there is no next question. So let's just see some base theorem and then we will see the questions based on the base theorem. So see, one thing you know, that let's suppose that you have some tree diagram here. I think abhi kuch bacha nahi base theorem mein. We have already covered all the possibilities of any type of probability that we want given the tree diagram. But yeah, for the sake of completion, let's have the base theorem also. Now, base theorem is basically for the backward reasoning, which means it is not the forward reasoning in the base theorem that we talk about. We talk about the backward reasoning, which means we say that if event B has occurred, then what is the probability that if event B has occurred, then what is the probability? Sorry. If event B has occurred, then what is the probability that it has occurred with A? Like I mean, for example, let's suppose that I have two bags. Okay, this is a bag one, this is a bag two. Let's suppose I have two bags, and in this bag there are red marbles, there are blue marbles. In this bag also there are red marbles and there are blue marbles. And there are blue marbles. Now, if I just say, let me go to the next page probably to explain this base theorem. It is for the backward reasoning, which means that if I just say that suppose that you initially pick some bag, maybe bag one you can pick, or maybe bag two you can pick with some probabilities, right? These probabilities could be half or half, or these probabilities could be some uneven probabilities, which is let's suppose 0.7 and 0.3. Now, Here, you may choose red, you may choose blue. This is one of the possibility. Another possibility, from here also you can choose red or blue. Now again, there are different probabilities here. Let's suppose this is 0.2 and this is 0.8. This is, let's suppose, 0.4. This is 0.6. Okay. Now, suppose we say that what is the probability that you already know that you have chosen the red marble. Okay, you have already chosen the red marble. What is the probability it has come from the bag one, right? Suppose I ask this kind of question, which means that I say that, okay, this has already happened. What is the probability it has happened with this? Which means that what is the probability that bag one, I have chosen the red marble from the bag one. So that is a reverse probability, or the reverse kind of questions that we will be asking in the Bayes theorem. Okay. So let me know if the problem statement or the objective is clear to everyone. Now, if you actually have to find out this particular probability, then what you will do? You will say this is as good as saying red and bag one divided by probability of red. So red and bag one means this particular probability, which is 0.7 into 0.2 divided by probability of red. What is the probability of red? It might have come from this or maybe this. So which is basically 0.7 into 0.2 plus 0.3 into 0.4. Right? Yes, Akash. So yeah, so basically that's how you can find out this probability, and that is what Bayes theorem says. So Bayes theorem is actually talking about the reverse inference. Basically, there is something called cause and effect. Okay, in machine learning, cause and effect. Like every cause will do some effect, and every effect has some cause. So basically, Bayes theorem is applicable there, or the Bayesian inference is applicable there. Okay, so I hope this is very much clear. Now, in terms of this particular abstract example in in terms of this tree, I can say probability of A given B will be probability of A comma B upon probability of B. Now, what is the probability of A given B? A comma B, that you can easily find out using the node probability, and probability of B will be, so probability of A comma B upon probability of B will be probability of A comma B, and B can also happen with the A complement. Okay. So that's what Bayes theorem is saying. Let's just see first the formal definition, and then we will see the examples of the Bayes theorem. So they are saying let A1 to AN are the disjoint events from the partition of the sample space. Do you remember what is the partition? Anyone? Do you remember what was the partition? What we call a partition? Okay. Yeah, disjoint and mutually exclusive, exhaustive. Sorry. So partition means they are disjoint. So let's suppose that A1 to AN are making a partition. Then you can say that if you want to find out the probability of any AI given B, I think that's overcomplicated. I don't think we need that kind of complicated definition. Okay. So let's just skip this definition. I mean, this is for the N events, but I hope you understood, right? So basically, if you want to find out AI given B, then what you can do for this B, you can marginalize. And since these AIs are actually making a partition, that's why you can marginalize. I mean, from here to here, you can do it only when the AIs are making a partition, right? Okay. So let's just see the examples directly. I think you will be more comfortable after that. Let's see this question. This question is saying bag one contains 3 red and 4 blue balls. Okay. So while another bag 2 contains 5 reds and 6 blue balls, one ball is drawn at random from one of the bags and it is found to be red. So first tell me the sequence of events. First, you will be choosing a bag, or you will be just choosing the marble, or you will be just choosing the ball. So you will be choosing the bag, right? It is very natural sequence of events. So you will say either bag 1 is chosen or bag 2 is chosen, right? And now, since they are saying that that random from one of the bag, you are choosing actually randomly from any of the bag. So maybe the probabilities are 0.5 and 0.5. And now from this bag one, maybe red or blue ball can be chosen. Similarly here, red or blue ball can be chosen. Now just tell me what is the probability that you will be choosing red wall given that you already have the bag one? What I should write here? Can anyone tell me using the given data? 3 by 7, right? Why? Because red are just 3 out of 7. So basically you will say 3 by 7 here, and then automatically whatever is remaining 4 by 7 you will be writing here. Similarly, you will be writing 5 by 11, right? 5 by 11 here. So can anyone tell me mathematically what is this probability? Notation wise, probability of red. Is this correct? No, right? So probability of red given back 2. Right? This is the probability of back given back 2. Yes. Red given back 2. Okay. Now they're asking that if you know that red is already chosen. Okay. If you know that red is already chosen, what is the probability that it has chosen from the second bag, which means bag 2? So that's what they're asking, right? The reverse engineer, the reverse question they're asking, which means the red is already given. See, generally in the forward inference, what you will be doing, you will be saying that, okay, given that bag 1, now what is the probability of red? It seems like very much forward, right? Now, if they're asking for the backward, then you can do it. That's not an issue, but you need to apply the Bayes theorem, or maybe you can do it with the intuition. I mean, there is no much problem here. I think probability of red you can find out, and red comma back 2 also you can find out, right? So let me know what is the answer here. So probability of bag 2 given red is equal to probability of red comma bag 2 upon probability of red. So what is the probability of red comma bag 2? 5 by 11 into 0.5, right? Upon probability of red will be 0.5 into 3 by 7 plus 0.5 into 5 by 11. And if I say that one of the answer is saying this is 0.37, Sakshi is saying it is 0.37. Okay, so most probability is 0.37, right? So have you understood this particular question? So actually we have already solved this kind of question, but for the sake of completion, we can have the Bayes theorem. Otherwise, it is not required once you know the tree method very nicely, right? Actually, I like the question that has been asked in Telegram group. So this particular question. Sorry, not this one. Yeah, this particular question. So that question was really nice. Okay, Twinkle, you can watch it later. This was really a nice question. And once you understand this question, I think that now the tree diagram will be very much clear after this question. Okay. Now let's just solve this particular question. What they're saying, suppose I have 3 die, or let's just do one thing. You can solve this particular question as a homework because I have the solution on the next page. Okay. Let's just solve. Let's just do these particular questions as a homework, and let's just directly solve the gate PYQs. Is this okay to everyone? Okay, because I have the solutions there, so I think you can solve it. So this is also easy question. The solution is on the next page, and that is also easy question, and the solution is on the next page. Now let's just do some of the gate PYQs. So let's just see what this question is saying. Consider, so that has been asking gate 2018. Now they are saying consider Guwahati and Delhi, whose temperature has been classified as high, medium, and low. Okay, so they have high, medium, and low. Guwahati and Delhi. Let Guwahati, like PHG is basically the probability that what is the temperature, like probability of high temperature in Guwahati, denote the probability that Guwahati has a high temperature. Similarly, PMG and PLG denote the probability of Guwahati having medium and low temperature respectively. Similarly, for Delhi, right, which is high, medium, and low. So basically what they are saying that Guwahati and Delhi can have high, medium, and low temperatures. Okay. Now the following gives the conditional probability, conditional probability for everything. Now they are saying that this is the one tree that they have given. Sorry, this is the one table that they have given for the conditional probability. Okay. Now, okay, actually the question was too big, so I have divided that question into 2 different slides. I hope that is fine. Now let's just see this. Consider the first row in the table above Okay. Actually, this is table below. So do you really want it to be above? Maybe we can do it above. Okay. So consider the first row in the table above. Okay. And the first entry denotes if the Guwahati has the high temperature and the probability of the Delhi also having the high temperature. Okay. That is, they are saying ki this is the probability that they have given in the table is actually denoting probability of HD given HG. Okay. Using the pattern, let's suppose I don't show you anything else. I don't show you anything else in this particular question. Using this pattern, can you tell me what is this probability? What is this probability in terms of notation wise? Basically, it is the Delhi probability given the Guwahati probability, right? I mean, that's the notation they have used. It is not any standard notation that you also have to do the same thing. Okay, it is not any standard notation. It is just that they are saying that they have used this notation because that is defined in the question. So in the question they can define anything. It is not like that if the table is given, then they have this notation only. No, I can also have, instead of the conditional probability, I can also have the joint probability distribution here, which means that this could like I can define like this, that this entry and the every entry is the joint probability distribution, which means, okay, can anyone tell me what do I mean by the joint probability distribution? Suppose I say that every entry is joint probability distribution, then what will be this particular answer? I think I've used this particular term once or twice maybe in one of the lecture. Joint probability distribution means you have probability of LD comma MG. Yes. Right. So I can say this is joint probability distribution. I can say it is conditional probability distribution. I can say anything. I can even say it is something like this. Probability of Guwahati maybe upper and Delhi may be lower. Okay. I mean, it depends on my notation. If I'm giving the question, it's not compulsory that you have to follow that notation. So anyway, now okay. So now they are saying that every entry is a conditional entry, and you have Guwahati on the given side, right? Guwahati on the given side. So they have given you the example of the first row that this is 0.48. This 0.48 means that given Guwahati temperature, which is high, the temperature of Delhi will be medium. I mean, this is the probability like that, right? It is also known that, so all the conditional probabilities are given to us, right? It is also known that the Guwahati, in the Guwahati, high, medium, or low temperature is also given. Okay, unconditional. Now they're asking that the Guwahati has the high temperature, given that Delhi has the high temperature, right? Okay, Delhi has the high temperature. H. This is what they're asking. Cool. So now tell me what to do. See, what they've given to me, they have given few probabilities, which looks like this. Probability of HD given HG. I mean, these kind of probability, given Guwahati probability they have given. And also they have given these kind of probabilities. HG, probability of MG, probability of LG, right? This is given to me. And I mean, these kind of certain probabilities are given to me. And then they have asked something, which let me just write here. They have just asked this thing, which is probability of HG given HD, right? Okay. So now what do you think that we should be using? I mean, should we starting? So basically, should we starting from Guwahati, Delhi? This is one thing. And then maybe temperature is, I think, यही possibility है. What kind of tree is possible? High, medium, low. High, medium, low. Now, given Guwahati, okay. Actually, there is I mean, there should be the relationship between the Guwahati and Delhi, right? So what kind of tree is possible here? Temperature first, then city. No, temperature city का debate नहीं है. I don't think like actually I have to have two cities in a sequence. मतलब Guwahati city के बाद I have to have the that city. See, these things are given, right? From this I think you can easily guess that I have to first say that Guwahati temperature medium, low or high. These are the three possibilities here. So see, this summation should be 1. That's all you need. And the Guwahati temperature, obviously the summation must be 1. 0.2, 0.5 and 0.3. Right? 0.2, 0.5 and 0.3. So you can say now the Guwahati temperature is high. This is the probability, and then these are the probabilities. And then they have also given this Guwahati, and now you can say that okay, this could be high. The Delhi temperature could be high, could be low, could be medium. Sorry, could be medium, and could be low. Right? And similarly here also high, medium, and low. What they're asking, probability that okay, these all see aren't to convince that these probabilities are given, which is 0.2, 0.5 and 0.3, right? Aren't you also convinced that these probabilities are also given? Do you agree that these probabilities are also given to us? Yes, right? And what are these probabilities which are using the table? Like, I mean, in the table, these probabilities are also given. So we have these probability. We just need to do the reverse, like inference, right? So we just ask that, I mean, they have just asked this particular thing. So I think you can do it as an homework. हो जाएगा? Okay. Or maybe I can solve it, or you can just ask me if that is doable. Okay. Anyone here who wants me to solve? I can quickly solve it. Okay. Twinkle, is this okay to you? Guwahati. Sorry, medium. Let me just make the diagram and then you can solve it later. Okay. Delhi. And all of these branch probabilities are given, right? All of these probabilities are given to us. And since all of the probabilities are given to us, you can ask any of the probability. We can find out any of the probability, right? So I think this is doable. Now let's just move to the next question. Okay. Let's just do this question, which has been asking GATE 2017. सर ये कैसे पता चला कि दिल्ली और गुवाहाटी ट्री ब्रांच में नहीं है? क्योंकि see what they have given to us is these probabilities. So most probably, if they have given these probabilities, so most probably that we are starting with this particular thing, this particular possibility, right? And now they have also given this that ki Guwahati or Delhi ko ek hi like we need to put all this Guwahati and Delhi in one of the sequence, because if Delhi Guwahati temperature is this, then this is impacting Delhi temperature, right? Guwahati temperature is impacting Delhi temperature. So we have to put them as a sequential events, right? If Guwahati temperature is this, then what is the possibility of the Delhi temperature? That is also given. So that's why, like, based on the given information, we need to make that tree. Okay. Now let's just solve this question. P and Q are applying, considering to apply for a job. The probability that P applies for the job is 1/4. Okay. So probability that P apply for the job is 1/4. The probability that P applies for the job, given that Q applies for the job, is 1/2. The probability that P applies for the job, given that Q applies for the job, is 1/2. Yeah, P, so like there seems some gadwad with P. P is a kind of guy who is like, I won't apply for a job, but if my friend is applying, then I will definitely apply. then my chance of applying is basically greater, right? So okay, maybe we have these kind of guy everywhere. Okay, so let's just read out this paragraph. Now they're saying P apply for the job, ठीक है ये हो गया, and the probability that Q apply for the job, the probability that Q apply for the job, given that P applies for the job, is 1 by 3. Then the probability that P does not apply for the job, then the P does not apply for the job, given that Q does not apply for the job, is what? Okay, that's what they're asking. Okay, let me just do one thing. Let me just copy that on the next page. So have you cleared that what they have given and what they're asking? So these three things are given. Let me just use the same color for the given. These three things are given and they're asking this. Okay. So what do you think? Should I make, see, there should be some relationship between P and Q. P apply for the job, P does not apply for the job. Q apply for the job, Q does not apply for the job. Q apply for the job, Q does not apply for the job. This is one possibility of the tree diagram. Another possibility is that Q apply for the job, Q does not apply for the job. And then P apply for the job, P does not apply for the job. P apply for the job, P does not apply for the job, right? Okay. So what do you think? Which tree diagram is more suitable here? Second one or first one? So what they're asking is that Q does not apply for the job and then P does not apply for the job. So if I choose this second one, then they're asking this direct probability, right? मेरे हिसाब से second one could be better because they're asking this as probability directly in the second one. And Q apply for the job or Q does not apply. Okay, they have not given this. Okay. They have given, see, in the second one, they have given this as 1 by 2. Okay, first of all, using these three information, I think you can easily find out probability of Q apply for the job or Q does not apply for the job. See, actually, whenever the actually like, okay, this is actually always in pair, P and Q. If you write it like this is probability of P into probability of Q given P, or you can write like this, right? Probability of Q into probability of P given Q. Now, here in this particular question, this is given, this is given, this is given. Can you find out this? Can you find out this? So what are these values? Let me just write down. Okay. So from here, probability of Q is actually probability of P 1 by 4 into probability of Q by P 1 by 3 divided by probability of P given Q, right? 1 by 2. So what it is coming out to be? 1 by 6. Okay. So from here, from the given information, you don't need to worry about probability of Q, which is coming out to be 1 by 6. I think now तो हो जाएगा. I think ये 1 by 6 है, ये 5 by 6 है, 1 by 2 है. This is 1 by 2, right? This is what they're asking. I think it is doable, right? So let's just assume that to be x. Whatever they're asking, let's just assume that to be x. This is 1 minus x. Now, can you find out the value of x? This is the question that is remaining now, right? Can you find out the value of x? So how to find out the value of x? You can, I think what you can do, the probability of P is given, right? Yeah, probability of P is given. So using this probability of P is equal to 1 by 6 into 1 by 2 plus 1 by 5 by 6 into okay. So instead of probability of P, let me use probability of P complement. Okay. So probability of P complement क्योंकि वो x डायरेक्टली निकल जाएगा ना वहां से 3/4. Okay, so let me use probability of p complement. So this is actually equal to 1/6 into 1/2 plus 5/6 into x equal to 3/4. So if you solve this equation, then you can get x, which is 4/5. Okay. So yeah, that was easy question. I'm like actually not easy question. I will say that was little nice and tricky question. First you have to identify कि वो कौन सा tree diagram. Actually you won't go wrong. Even if you choose this one, maybe like from here and there, you can finally find out the answer. You won't go wrong. But yeah, if you choose the directly that particular diagram where they are asking about the forward reasoning, then it is always better, right? So that's how you can solve this question. Let me know if there is any doubt here. Okay. Now let's solve this question. What they are saying, an unbalanced die with 6 faces. Or unbalanced die means that you may be having you may be having any like any number can come from 1 to 6, right? I mean, it depends on the probability. Probabilities are not even. This is not uniformly distributed. A question can be multiple diagram or always two. Like I don't know, like it depends on the question, maybe number of labels. If the number of labels is just 2, then probably this is just two possibilities. Maybe if number of labels are more, maybe multiple possibilities, right? If this is only p and q, then we are just debating either you're putting p first and q next, or if you have p and q are, then maybe you have 3 factorial possibilities. I don't know, like based on the question you can argue about it, right? Okay. Now an unbalanced dice with 6 faces from 1 to 6 is thrown. The probability that face value is odd is 90%. Okay. Probability that face value is odd is 0.9. Of the probability that face value is even. Okay, 0.9 into probability of face value is even. The probability of getting any even number face is same. Okay. Probability of getting even number face means 2, 4, 6, right? If the probability that face is even, given that, if the probability that face is even, given that it is greater than 3, face is even, given that it is greater than 3. Okay, 0.75. Which of the following option is the closest probability of the face value that exceeds 3? So they are asking probability of greater than 3. Let me do one thing. Let me copy this whole thing in the next page. कैसे करना है? एक और information they have given कि even face probability is same, right? Probability of getting any even number face is same. Okay, so they have given probability of 2 equal to probability of 4 equal to probability of 6. Let's assume that to be x. Okay, let's assume that to be x. Then what is the probability of even? It is given. Okay, what is the probability of even? That is 3x, I think, right? Because that is probability of 2 plus probability of 4 plus probability of 6. Okay, I think we can find out the value of x. How? Because probability of odd is 2.7x. Probability of even is 3x, right? सही है ना? हाँ. Now you know that probability of odd plus probability of even is 1. Why 3x? Because even could be 2, 4, 6. And probability of 2, 4, 6 are equal to be x. Okay. So odd plus even is 1. and then you can say this is 5.7x, right? So x is 1 upon 5.7. And which is probability of 2 equal to probability of 4 equal to probability of 6. So can you find out the probability of 1? Can you also say probability of 1, 3, and 5 are equal? No, actually I can't say, right? Because it is not given in the question. In the question it is not given, so I can't say. Only it is mentioned that even phase probabilities are same. They haven't mentioned anything about the odd phase probabilities. So anyway, like the even phase probabilities I know, which is 1 upon 5.7. Okay. Now they have given, let me just see that what else they have given, and then we will see if we can find out the answer. Okay. They have given probability of even given greater than 3 is 0.575. What does this mean? This means probability of, actually if you can't apply the intuition, that's fine. Just use the formula. Even and greater than 3. It means what? 2, 4, 6, 4 or 6, right? So it is 2x. 2x upon probability of greater than 3. Greater than 3 means 4, 5, 6. Okay. Probability of greater than 3. Let me just write greater than 3 only. आ गया ना आंसर 0.75 है ना ये तो x की वैल्यू we already know, so you can find out probability of greater than 3, right? Is this okay to everyone? So 2x upon probability of greater than 3 is 0.75. That is what we just concluded. And 2 into 1 upon 5.7. And this is into 1 upon 0.75 equal to probability of greater than 3. Okay. So what is the answer you're getting? Probability of greater than 3? 0.468. Have you understood this? Like I just followed what is given in the question. So I just assume that to be x because all are equal. And then from here, I first find out the x. Then once you find out the x, then you can just simplify this. And from here, you are getting the probability of greater than 3. Very easily you are getting, right? Okay, 0.468. Okay. So Pawan is saying random, why we can't use a redistribution of the probability method? See, that is just an intuitive method, and I don't suggest you to use the redistribution and all. I strictly and again, and so I don't know why it always happens that if I'm saying that do this, then experiment will say no, 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 I will not do this. I will do something else only. So if I say that don't do this, then why the aspirants only interested in doing that? So if I'm saying that don't, that is just a intuitive way to understand the probability formula. Okay, don't try to put it everywhere. So if you do it, you will get confused. Just use the simple formulations. Okay. So if you want, maybe we can try also, but I won't recommend it. Let's just try doing it. So what they're asking is that they're asking that probability of even greater than 3. Actually, मुझे खुद को नहीं पता क्या करना है, but let's just see. 0.75. Okay. Probability of even greater than 3. Initially, you have some probabilities of 1, 2, 3, 4, 5, 6. Okay, this 1 is having some probability, 2 is having some probability, 3 is having some probability, 4 is having some probability, 5 is having some probability, 6 is having some probability. But after greater than 3, these probabilities are 0, right? I mean, initially you have some values. You have some values here. But after greater than 3, these probabilities are 0. And you have to just find out these 3 probabilities. Okay. Can you find out earlier whatever is the probability there? You just need to divide by the probability of greater than 3, right? So earlier, whatever is the probability, here, earlier here, it was x, right? It was x and it was x. And probability of 5 you don't know. Probability of 5 you don't know, right? So let's just call it probability of 5. Now, can you tell me what is the probability, new probabilities? What are the new probabilities? Can anyone tell me? In terms of formula, just tell me. In terms of the abstract way only. What number I should be dividing here to normalize it? What number I should be dividing? X divided by probability of anyone? X divided by what number I should be dividing to normalize it? See, this must not be normalized, right? Yeah. So x divided by probability of greater than 3. Probability of 5 divided by probability of greater than 3. Probability of x, x divided by probability of greater than 3, right? So these are the new probabilities. Is this okay to everyone? And now in the new probability setup, they are saying this is not okay. Okay. So have you watched that lecture that we need to normalize it, right? So for the normalization, you need to divide the probability of B. If the B event has already occurred, you need to divide by the probability of B. So that is what we already covered in the earlier lectures, that if whatever event has already occurred, you need to make all of that sum as one. See, let me just explain this again. See, what I'm saying here is that if we have this diagram, now you are confused what to write here, right? You're confused what to write here. Ultimately, see, currently this summation will not be 1, right? What is the summation? The summation is probability of greater than 3, isn't it? I mean, just don't look at this particular line. No, don't look at this particular line. Just tell me what is this summation earlier, because we are always talking about this P. Have we ever written Q or something like that? I mean, are we talking about some other probability distribution? No, right? We always talk about this P. Now, just tell me what is this 3 summation? This is just a probability of greater than 3, right? This is probability of 4 plus probability of 5 plus probability of 6, isn't it? Right? So, yeah, okay, Pavan, that's very nice point. So you can divide by 2x plus probability of 5 also. So actually this, I'm dividing by probability of 3 at both the probability greater than 3. But yeah, you are right. Greater than 3 I'm dividing just to make it 1, make it as 1. But you are saying that why we are not dividing by 2x plus probability of 5? Yes, you can divide it. Actually, both are same. Probability of 3 and probability of greater than 3 and probability of 2, 2x plus probability of 5 is both are same. So you can divide by 2x plus probability of 5 also. Okay. So it is just a probability of 3, right? Okay. So here you divided by this, and now these are the new probabilities. Now you know the summation of these 3 probabilities should be 1, right? Summation of these 3 probabilities should be 1. So now, okay, now even, okay, now if you talk about this even greater than 3, which means now you are in this reduced domain, and now here, can't you say that this summation, these two summation should be 0.75? These two summation should be 0.75, because greater than 3 means now you are talking about these probabilities, these 3 probabilities, right? Now here, now just forget about this. Now probability of even is x upon probability of probability greater than 3 plus x upon probability greater than 3. That should be equal to 0.75, which means from here you can say 2x upon probability of probability greater than 3 should be 0.75, and now probability greater than 3 is 2x upon 0.75. I think it should be same, right? 2x upon 0.75 probability greater than 3. Okay. So anyway, like I just suggest you to not mess up with this. Just use the formula. That's what I said, right? Okay. Now let's just solve more questions. Let's just solve this question, which has been asking Gate 2016. And then, yeah, this is the one last question that we have in the conditional probability in the gate PYQs. So we have solved all the gate PYQs which are related to conditional probability. Maybe one or two might be left, but I will just see if something is left. Okay, so let's just solve this PYQ. Suppose that a shop has an equal number of LED bulbs of two different types. The probability of LED bulb lasting more than 100 hours, given that it is of type 1, is 0.7. Okay. So first tell me, given that it is type 1, lasting more than 100 hours, something like this, right? First tell me, should you be choosing the type, or you should be first choosing more than 100 hours or something? Type, right? So it could be of type 1, it could be of type 2. Actually, there is no particular formula or particular thing. It is just by intuition, but like you need to check that, okay, what is the sequence of event that is more comfortable with this given question. Okay, so type 1. Now in this type 1, they are saying that it will last more than 100 hours is basically some probability which is 0.7. Now last more than 100 hours, less than 100 hours, or less than equal to 100 hours, last more than 100 hours or less than equal to 100 hours. So given that it is type 1, now tell me, can I say that this particular node probability is 0.7? Is this correct? This particular node probability is 0.7. Is this node probability 0.7 or the edge probability 0.7? Right? Yes, Twinkle, that is correct. So we have the edge probability, which is 0.7. So this is the probability that is given to us, which is 0.7, right? And that given that it is type 2, lasting more than 100 hours, given the type 1, okay, this probability is given 0.4. Tell me, do they have to give these two probabilities? No, right? I mean, this is 0.3 by default, and this is 0.6 by default, right? Yes. Now, type 1, type 2 probabilities, what are the probability LED will chosen randomly, uniform randomly. So that's why this is 0.5, right? Uniformly randomly. That's why it is 0.5. Okay. Okay. Now you have the complete tree. So now you can find any probability that is being asked. The probability that the LED bulb chosen randomly at random last more than 100 hours. So I think they are asking about these two summations. You can find out these two summations, right? Which is actually equal to 0.7 into 0.5 plus 0.4 into 0.5, which is 0.5 into 0.11, which is 0.45. Is this 0.55? Yeah, 0.55. Okay. So the final answer is 0.55. I think that was easy question. So actually we have covered this conditional probability in so good detail that you should not be able to, you should be able to solve all the questions. You should not, you won't be stuck in any question that is as per the gate level. Obviously, if they ask any machine learning question, then you will be definitely, most probably you will be stuck in there. But if they ask as per the gate level or TIFR level, you should not be stuck. Because see, once you make the tree, then everything comes very naturally. And in this conditional probability questions, you just need to make the tree. That's all, right? So that is all for today. I think we have covered all the questions that we had. Now 0.55 is the correct answer here. Now what you can do, if you are interested, then what you can do, you can just explain this tree method on the gate overflow, because most of the answers on the gate overflow are not using the tree method. So actually I don't find that much time to put all the answers on the gate overflow. That's why I'm just requesting you to let everyone knows that you are GoClasses student, right? Just type your answers, just make a nice diagram, either using pen and paper or using some PPT or something, and make a nice diagram, put that diagram in the gate overflow, and just explain these questions using your own method, which is the tree method. Yes, Gaurav, as dominates the conditional probability. So as is dominates the conditional probability, that is what we already covered a few times. See here, if you have A, you have A complement, this is B, this is B complement, then this probability is probability of A, this probability of B given A, this probability is probability of A comma B, right? Okay. So that's all I wanted to cover. Let's meet day after tomorrow. Okay, day after tomorrow is I think Wednesday, so we might not be having a live class, but we will be having a quiz. So I think the quiz will be from first order logic. I will ask Deepak. If that is not from the first order logic, then I will take a quiz regarding this conditional probability. Or maybe let's do one thing. Let's have two quizzes this week. Okay, so let's have two quizzes this week. One is from the first order logic, another one is from the conditional probability. Okay, so we can do it. Is this okay to everyone? Okay, no mixed quizzes. Like we generally don't want to prefer. We want to mix quiz. We will be like putting two quizzes instead of mixed quiz. Okay. Did you discuss Aditi's doubt? I don't know what doubt she is having. So you can just send me now if you have that. You can just send me the screenshot on the Telegram or WhatsApp. Okay, just tag me there quickly. Okay, just let me know. What is the difference between option D and option C? Option C there is saying that this is just joint probability and this is the conditional probability. Like, I mean, so there are two options, right? One is that A1 intersection B1, B2 intersection C1. Another one is C1, given that. So what is confusion here? Nodes are the event, not the probabilities. No, nodes are also this. This is the node probability, right? This is the node probability. This is the probability of the circled node. This is the probability of the circle node. In that particular question, this is the probability of the circle node is having the probability, right? Node is the joint probability. Node is a joint probability, and edge is the conditional probability. Okay, yes, options must be having this probability. Yeah, actually, that question I have taken from Stanford or maybe MIT. Actually, one of them. I'm 100% sure either from Stanford or from MIT, and maybe they might not be having PH notation, but yeah, this P must be there. Yes. Okay. So they were just abusing the notation. So some professors just like to have their own shorthand notations, but this P must be there if you talk outside that particular class. So that might be limited to that. Sometimes in the ISC also you will see that in ISC or IITs, like sometimes the professor use their own notation. I mean they just have the shorthand notation. Okay, but outside those that particular class, those notations are not valid. But must be very, very obvious. That's the only reason they skip. So yes, P must be there. English interpretation of this, the probability of A1, B2 and happening A1, B2 and C1 together. Means A1 will happen, A1 along with the B2, along with the C1 will happen. And here you already know that A1 and B2 has happened. What is the probability that C1 will happen? Okay, but here you don't know the A1 and B2 or has happened or not. The probability that all of them happen together, and this is that the probability that A1 and B2 has happened. Now, what is the probability that C1 will happen? Okay, cool. In the tree diagram also, you can probably see the difference that okay, what is this representing and what this is representing. Okay. Simultaneously means no, simultaneously it is not simultaneously in terms of the time. Okay, time might be different. If you are doing the sequence of events, then first maybe A1, then B2, maybe C1, like that. If you are tossing a dice and tossing a coin also, then maybe you're first tossing a coin and then you're tossing a dice. It might not be like you're doing both of the things simultaneously. Okay, with respect to time, need not to be simultaneous. It is a sequence of events. सर डाइस वाले क्वेश्चन में वाला ट्री डायग्राम कैसे बनेगा? Which one? That I gave you a homework today. That's what you're asking, Manish? So since that is homework, you can do it. Okay. Which one? Actually, if you're asking something that uska tree diagram kaise banega, to be honest, maybe if there could be a rare occasion also जहाँ पे tree diagram itself might be confusing. तो अगर वो नहीं बन रहा है तो भी ठीक है, मतलब जरूरी नहीं कि tree diagram से ही करना है. Okay, so if you are not getting the tree diagram in that particular question, so there might be some rare question where the tree diagram might not be suitable. Just skip it. It is not compulsory that you have to do it using the tree diagram. Okay, it is for our convenience, not for the inconvenience. So if you are not able to do some particular question that might be a rare question, then using the tree diagram, then also it is fine. Okay. So I think there was one question. If we do it using tree diagram, we were just making it complicated, right? Today only. ये था शायद, है ना? कुछ ऐसा ही था. I think यही था. So if you're doing the tree diagram, then in this question we are unnecessarily making it complicated. So like if we can directly use the formula, then why not? Okay. So thank you everyone. Let's have two quizzes this particular Wednesday. One is for the proportional logic. Another one is for the conditional probability. Yes, on the Wednesday itself we can have both. That is valid for 3 days. So I think 3 days, just 40 minutes quizzes should be fine, right? Okay. So thank you everyone. Take care. Bye bye.